Well, this particular class is really structured to help the faculty to be able to get ideas of how we can integrate STEM with advanced manufacturing. So one of the things that we wanted to do is to be able to think out of the box, that we don't want to be working in silos in terms of each academic disciplines. What we want to show is that how everything interrelates, and that how someone can have a great idea and turn it into from concept all the way to the finished product.
We started with a grant that encompassed the development of guitar making through STEM activities. We've expanded that to include curriculum development, career pathways, and trying to connect what we're doing with our grant to national standards and local standards for different schools.
It evolved out of work that started at Purdue University. I started building guitars there almost by accident, and started doing workshops, and that evolved into this, the projects like you see here. Guitars turn out to be a pretty good tool to use for teaching math and science and engineering. There's enough complication in it that to have some real meat, but it's still simple enough that somebody can learn to build one in a week or so. It's well within the abilities of most high school students.
We have about a dozen schools that are implementing and training. So we have faculty at these schools who are helping us develop curriculum, going out to different places around the country, different institutions, and developing the curriculum and the activities.
I knew instantly that the guitar was going to be the perfect instrument, the perfect object for teaching STEM concepts to high school students. And quite obviously, all high school students really love music. Most of them are somewhat familiar with the guitar, but they really don't know until you teach them about all the mathematics involved on the fingerboard, all of the physics involved with vibrating strings. You've got, waves and waveforms, waveform analysis that you can do with it. I can teach basic electricity with the guitar, so I take my students from, voltage, current, resistance, all the way up through the concepts of capacitance and inductance in a DC situation and an AC situation. And in the meantime, the students are building the guitar.
A lot of the students, they don't really see the connections between what we're teaching them and what they're going to need to do in their future. They feel like we're just giving them some useless facts. I remember feeling like that when I was in high school and college, of how does this relate to me? Why is this even interesting? So things like this Guitar Institute are going to help me to bring more authentic experiences to my students so that they understand where the benefits of learning mathematics are.
Students who might not otherwise find something that maybe their whole career they've gone along and school has just been, it's just been a burden on them, and now they found something that they can do that they can feel good about. They are motivated to do really, really good, high quality work on their guitar. And I had a kid come to me and say, now I have to do good work in all my classes.
We got a lot of students who don't know how to play. And it's one of the things we have to reassure them about. If you don't know how to play a guitar, that's not that important. You can understand the science, the math, the engineering without knowing how to play. Now certainly it helps, but it's not a deal breaker.
What we've been doing here with this guitar building workshop is actually integrated into our current program. So we have manufacturing processes courses, we have manufacturing materials courses, so the process of manufacturing a guitar builds right into those courses that we already have.
The ones who come to us or comes to the teachers without knowing how to play will often at least start learning how to play when they're done. What they'll find out is that the basics of music are mathematical and follow the same kinds of rules that other mathematical things follow, and they're able to put that together and learn at least the basics of how to play the guitars. It's fortunate that modern music is based on very simple patterns, and those patterns are mathematical and they're easy to pick up.
In this NSF grant, we've seen many teachers through our summer workshops, and always what comes back to us is the excitement from those teachers. And we know that excitement they're going to be taking back to their classroom, which is going to motivate them and to help their students be more successful as well.
We don't have any problem at all getting kids interested in making guitars. We don't have to twist anybody's arms. They come to us. And so when they come to us with that kind of enthusiasm, that creates a learning moment that's hard to duplicate.
It's something that I'll be able to take back and show them, hey, this is what we're going to make. It's not, I can't just tell them a story about it or look, give them PowerPoint. This is something that I've built with my hands, and as soon as we'll be able to tell, wow, can I touch it? Can I see it? Can I play it? So this is really cool. I like the process, using my hands and getting something built, but also being able to show them a real object, something that really works, that I built myself.
At the end of the project, the students who have learned how the guitars are made, they've learned the engineering and the math and the science behind it, have a completed playable guitar to look at, and the pride and the sense of accomplishment they get out of that, it's really easy to see. It's a real transformational thing for them.